So the lesson 9 practice problems here, we've got for number 1, an image of a book shown in a website is 1.5 inches wide and 3 inches tall on a computer monitor. The actual book is 9 inches wide. So what scale is being used for the image? So what I think is the first thing you want to do on this one is start comparing corresponding values. You know, we've got right here it says the actual book, the width of the book is 9 inches, okay? And also is mentioned right here, the width of the the picture, the scale of it, the scale drawing of it is 1.5 inches, 1.5 inches wide. All right, and so what you want to do for that is just, and I'm going to look here, the actual book is 9. Yeah, so we're going to do, what scale is being used. I'm going to do 1.5 divided by 9. So when we do that, what are we going to get? Just trying to do this in my head. We got, oh, you know what? It's going to be 6. All right, so I can say that there's like a 1 to 6 relationship right there. We can also state this, that 1 inch 1 inch equals 6 inches for the real thing, and this is scale, of course. All right, for B, it says how tall is the actual book? And, well, the height of the book is stated as being 3 inches tall. So all we have to do is just do 3 times 6, which is going to give us 18 inches. All right, so there's that. For number 2, the flag of Colombia is a rectangle that is 6 feet long with 3 horizontal stripes. Okay, so this is 6 feet right here. That's the real life measure. That's 6 feet. All right, the top stripe is 2 feet tall. So this right here, that is 2 feet. That yellow stripe at the top. The middle stripe and the red stripe are both 1 foot tall. So that means if just do some basic adding there, that's 4 feet. Okay, so the flag is, the typical dimensions are 6 by 4, like a 3:2 ratio. That usually happens with flags. Typically, they're not all that way, but a lot of them are. So what do we got to do? So create a scale drawing of the Colombian flag with a scale of 1 centimeters is equal to 2 feet. 1 centimeter equals 2 feet. So what I want to do here is, like, for the width, I'm just going to kind of map it out here. The width is, the actual width is 6 feet. The actual width is 6 feet, and what we're going to do is 1 centimeter is going to equal 2 feet. And so if we just divide that by 2, we're going to get 3. So I want to make the drawing 3 centimeters. Okay, that's the drawing value right there. All right, the height. The height is listed as well, it's 4 feet. I don't think I have to go even look at it. That's 4 feet. So if I divide that by 2, you get 2. So you're going to make your scale drawing 3 centimeters by 2 centimeters. Also, that's for the entire flag. That's for the entire flag. And then for the stripes, when you do the yellow stripe, when you do that, that's 2 feet. So you're going to do 2 divided by 2. So you want to make that 1 centimeter. And then the blue and the red stripe are both the same size. And those, you're going to just do 1 divided by 2, which is going to be 1/2 centimeter. Together they make 1 full centimeter. All right, and so I'm not going to really do this a lot of justice, but your drawing could be a lot more accurate. But I just want to just make a drawing here. This is pretend in this drawing that this is, kind of do this right. Right there, this is 3 centimeters this way, and then it's 2 this way, and then you don't have to, I'm going to color it in. So you got that. Better blue. How's this? It looks like purple, but whatever, I'll just use that. Got that, and then the red. Okay, if you want to put some more measurements in here, this right here is 1 centimeter. This right here is 1/2 centimeter, and so is the other one. And then for B, it says create a scale drawing of the Colombian flag with a scale where 2 centimeters is equivalent to 1 foot. So 2 centimeters. So since the flag in real life is 6 feet, so I'm going to do for the width, again, I'm going to just kind of map it out here. The width, so we're going to do this, so we got 6 feet, and I'm going to multiply that by 2. Okay, so that's going to be 12 centimeters. All right, so this is just a different scale drawing. It's not the same one we just did, but that's going to be 12 centimeters. And the height, we're going to do the same thing. We're just going to multiply that by 2. And the height of it is, what is it? It's 4 feet, right? So you're going to do 4 feet times 2, which gives us 8 centimeters. All right, now my picture is not going to be perfect, but I'm just going to draw and just kind of label what everything should be. But this is 12 centimeters right here. This is 8 centimeters right here. Okay, this right here is 4 centimeters. And then both of these other stripes are 2 each. I'll color it in again. There's the yellow part and the blue part. All right. So, a little sloppy, but my main deal is I want you guys to see kind of just how it should be laid out. When you're working on this on your own, you're probably using a ruler, trying to be a little bit more accurate. I'm just doing this to kind of show you, like, okay, these are the dimensions. Try to copy that. Okay, did I do all that? I did. Okay, for number 3, for part 3, these triangles are scaled copies of each other. So they're all scaled copies. So what do the directions say? For each pair of triangles listed, the area of the second triangle is how many times larger than the area of the first. So we're looking at second triangle. So we're looking at the second triangle and then comparing that to the first. So Yeah, it's like kind of confusing the way that's listed out, where it's written out there. But yeah, so for the first one, we're gonna look at F to G. So F to G, and I know this right here. This is 10 on F, and this is 5 on G. All right, so we're gonna go from, yeah, we're gonna do this, right? How many times larger? Just want to make sure I'm doing this right. Okay, so if we look at that one, we're looking at F to G. So looks like we go 10, 5, which is 2. Now that's the scale factor. The scale factor equals 2. All right, now one thing I kind of just glossed over here is that this is area. Okay, so we're looking at the area. So remember, area is going to be a squared relationship to scaled factor. So if the scale factor, whatever the scale factor is, square that value, and that'll be how much larger the area, or how much smaller, I guess. But you're going to square that value. So we're going to do, for this one, just do 2 squared, right? Which is just 4. So that's 4 times larger, the area. All right. The scale factor was twice as big, but area-wise, area kind of has this squared relationship, and that's what's going on there. Okay, so triangle G and B. All right, so triangle G, let me just kind of erase some of my markings here. G and triangle B. So I don't know, right here we've got, there's 2. I mean, I can use any number, but I like this number because it matches up with another whole number right there. Whereas, like, it's not impossible, but like right here, this is 5 halves, and that matches up with 10. So it makes the math a little bit more complicated, but not impossible. But yeah, we have a 2 here, and oh, I'm doing the wrong one. We're doing B to G. Going that way, right? That's what we're doing. So B to G, and so that corresponds with that one right there. And so I'm going to do 2 to 4. 2 to 4, and that reduces to 1/2. All right, so that's our scale factor. Our scale factor is 1/2. So our area is going to be 1/2 squared. 1/2 squared is going to be 1/2 times 1/2, which is going to be 1/4. Okay, and actually that's smaller, right? 1/4 is a smaller fraction than 1/2. All right, F to B. Okay, so for F to B, what can we do here? We can do, oh, this is easy. What I was going to do before. So you got 2 to 8. So I'm going to do 2 divided by 8, which is easy. That gives you 4. So your scale factor is 4. And so then your area is going to be 4 to the second power times bigger, which is 4 times 4. Not 4 plus 4. It's 4 times 4, which is 16 times. So the area of that one is 16 times bigger. Meaning, like, you know, we could, well, I'm not sure if this would work out perfectly, but we could probably fit that well, not probably, definitely, we can fit 16 of those triangles into the triangle that represents F. So put 16 in there. All right, triangle F and H. So you got F and H. All right, what is good ones to compare here for F and H? All right, there's a 2 here, and there's a 6. And so I'm just going to do 2 to 6, which reduces to 1/3. All right, so your scale factor is 1/3, and so your area is going to be 1/3 squared times larger. Okay, so that's going to be 1/3 times 1/3. In case you're wondering, that's kind of how it looks. And so 1 times 1 is not 2. 1 times 1 is 1. All right, and then 3 times 3 is 9. So there you go. All right, G to H. G to H. Let me it's getting kind of sloppy over here. So G to H. Right here, you got a 2 and we have a 3 here. Those are nice numbers to use because those are both whole numbers. Those are nice and handy to use. And so that's just going to be 2/3, and I don't have to simplify that. That's your scale factor, 2/3. And just figure out the area by just doing 2/3 squared. 2/3 times 2/3, which is going to be 4/9. 2 times 2 is 4. I'm putting this in a spot where you can't see. Sorry. 2 times 2 is 4, and 3 times 3 is 9. And then for the last one, right there, we've got H and B. So H and B, what are some good numbers to use here? You know, I can't get away with that one. So on H, let's do this. Let's compare these two right there. And so I'm going to do 2/3/2. Now that's what you call a complex fraction, all right? Which means just basically 2 divided by. I wrote that wrong. Sorry, it's 3/2. I wrote 2/3. 3/2. So that means 2 divided by 3/2. And then when you keep change flip, you get 2/1. You keep that. Change that to multiplication, and then flip that, and then you get 4/3. And you know what? I think I did this backwards. Let me fix this. Pardon me. I'm going to do it the other way. I want to do 3/2 divided by 2. So we do 3/2 divided by 2, keep change flip, and then you get 3/4. Okay, so there's your scale factor. And so your scale factor, you want to square that to get your how many times the area is greater, and that's going to be 9/16. For problem number 4, it says here is an unlabeled rectangle followed by other quadrilaterals that are labeled. All right, so select all quadrilaterals that are scaled copies of the unlabeled triangle. Now the thing that sticks out for me on the unlabeled triangle is that the length of it is double the width, right? 4 by 2. That's a 2-to-1. I mean, if you want to think of it that way, or 1 to 2. But yeah, you got that relationship right there, where this value is half that value. All right, and What we can do right off the bat, and just let's get this out of the way right now, these definitely are not to scale because the angles are not the same. So we have different angles in there, just get rid of them. Okay, and so now just kind of, I'm not going in any specific order here, but let's start with D. Now D right here has those characteristics that we want. Right here, this is 2, and that's 1. And so that has a 1/2 or a 2-to-1 relationship, depending on how you look at it. So right there, that is the scale. Right there. So right here, this is on C, that's 3. And if this is 6, then that's the scale, which it is. So that's the scale. See, it's pretty simple to find this. Right here, this is 2, and this right here is 2, this is 5. And so that is definitely not a 2-to-4 or 1-to-2 relationship, so that is not to scale. Still a rectangle, but it's not to scale. All right, for B we've got, this is 3, and this is definitely not 6 right there. That's definitely not. So that is, what is that, 1, 2, 3, 4, 5, 6, 7, 8. All right, so again, another rectangle, but not a scaled rectangle. And then for H, we've got 4, and if the width is 8, then that's the scale. So we got 1, 2, 3, 4, 5, 6, 7, 8, and indeed it is to scale. So there's all the rectangles that were scaled. Oh, I forgot E. We do that, and then for E, you've got 2, and this is 4, and that right there is, I mean, that's the exact same rectangle. Its scale factor is 1. So it's not, but it's okay to have a scale factor of 1. And for part B, it says, on graph paper, draw a different scaled version of the original rectangle. But I mean, all you have to do, and you know, on your paper, is just make sure whatever you do draw, like whatever this number is, you know, whatever that number is, I'll just put n there. Whatever that is, this is going to be half of that. Okay? So if you use, for instance, like let's say you used, if you use 10, then this should be a 5, right? That's should be how it is. Or if this is 24 centimeters, this is going to be 12. You know, it kind of just depends on what numbers you use. If this is 1 centimeter, then this is 1/2 centimeter. So you can see where I'm going with that. That's it.